To get you excited about the lab as well as build a little bit of background, let me start out with this example. So here is you, this is your laptop, and you are plugged into the internet. So this is your local network, which in turn connects to the IITB network, and you have all these names you have heard of: IITB web server, Netmon, so on and so forth, which in turn is connected through another router to the rest of the internet, and this is like the Google server. There are other servers as well. Now suppose you open a web browser and type this particular URL, we will find out what will happen. Guess the number of messages that will be exchanged from the time you click the URL to the time you actually see the web page. Many of you would have gotten this wrong. Let's see what's happening. First, let's understand a little bit more about your laptop, that is the host. Hosts typically are assigned a name. I'm a big fan of Asterix and Obelix, so I named my desktop Asterix. I'm also a big fan of Lord of the Rings, so my laptop is named Silmaril. Typically, web servers give the name something like this. So for example, the Google web server would have assigned a name of like this to the web server. Hosts also have an IP address. This is configurable and it depends on the location. For example, the IP address you are assigned when you are part of IITB will be different from the IP address you will be assigned, for example, when you are in Delhi. Hosts, rather the interface a host possesses, typically has a MAC address. This is fixed, so no matter where you go, that MAC address of your laptop is going to be the same. So why do these machines have so many identifiers? This is like your name, and then you have a pet name like Chotu or Nani, which your family fondly calls. So the reasons here are not quite due to fondness, but more for practical purposes. Humans as such are good at remembering text, like something like this, whereas machines such as routers or switches are more efficient at handling things that have a structure. So basically some byte arrangement. So this translates into IP address or MAC address. So humans remember names or web URLs, and machines handle IP addresses or MAC addresses. So naturally you need a method of converting these names into these IP addresses. For example, it's easy for you to remember the URL of Google but not the IP address of Google. So you need a service that provides host name to IP address translation, and that service is through the DNS. So here are a few useful things to know. For example, if you have Linux and you open up this file, this tells you what is the name assigned to your machine. And host is a command line command that I will show you shortly, which provides DNS service. Ifconfig is also a command that provides information on your network interface. By the way, you can use this command to also change some configuration like assign an IP address and so on and so forth. Man pages provide useful information on how to run commands. So here you can see this in action. This one I have actually opened that / etc host name, and as you can see, this is showing the name of my computer, which is Asterix, and you can see that here as well. So this one here is the file called / etc / resolve.conf. Again, if you open it in Linux, it will show something like this. So this is the name of the IP address of the server that is going to provide DNS service. And here is a man page. Basically, I typed man ifconfig, and this is what it shows. You can type man ping, you can type man root. These are some of the commands that we will use. So to get to know information, this is a useful page to reference. So here is host in action. For example, if I want to know what is the IP address corresponding to our web server, if I type host and the name of the web server, this is telling me that this is the IP address corresponding to this. Similarly, if I type host netmon, this is the IP address that corresponds to this. And I can also find outside host, for example, Google, it has many IP addresses because these are all different machines. It does load balancing. That is why it has different IP addresses. So the host name you can figure out through the / etc. / host name. But if you want to know what is your IP address, if you type this command ifconfig eth0, eth0 is the Ethernet interface. It tells you what the IP address is. And here is the MAC address of that particular interface. So this is in hexadecimal. So getting back to our story, where were we? So the user clicked this URL and he needed to contact this particular web server. Remember, you need whatever packets go out need to have the web server's IP address. So the first thing you need to do is contact your local DNS server whose IP address you know is in this particular location to get hold of the Google's web server. So that's where we are. So how do you contact this local DNS server? So in order to contact this local DNS server, local means it is within the same local area network, that is, it is your next hop neighbor. In order to send a packet to it, you need to know its link address, that is nothing but the MAC address. So now if you know the IP address of the DNS, local DNS server, now you need to find the MAC address of the local DNS server. Again, ARP is a service that provides IP address to MAC address translation. So here is ARP in action. I just typed the command ARP and it showed two entries. One is this cygnus.it.iitb.ac.in. I am just trying to resolve it. So I typed host and this is the name server which you saw in the etc resolve.conf. There is also another entry. This is the router. We will get to that shortly. So basically these two hosts are extensively used because for anything you need to do a DNS lookup and for anything you need to contact your router. So these entries are cached. But in case this entry is not there, ARP protocol basically sends out messages to figure out that information. We'll see that again shortly. So where are we now? So again, let me refresh your memory. So the user clicked google.com. So you need to know the Google's IP address. To determine this, you contacted your local DNS server. To contact the local DNS server, you figured out its IP address through this. By the way, this one you configure either manually or you obtain it when you set up your own IP address. And once you have the DNS IP address, you determine its MAC address through ARP. Now you are ready to send a packet to the DNS. So you send the packet to the DNS server and you get a reply from it. After this stage, you know the Google's. Now that you have Google's IP address, you are now ready to send the HTTP packet. As soon as you create this HTTP packet, it in turn triggers a TCP packet. Now this TCP packet, when you put it in the IP header will have the source IP address as your own host IP address and the destination IP address will be that of Google. Now who should you send this particular IP packet to, or rather the TCP IP packet? So a reiteration of what I said, this packet will have source IP as user's IP, destination IP as Google's IP, source MAC as user MAC, but whose MAC, destination MAC are you going to put? That's right, you need to pass it to your next hop router, which will in turn pass it through the internet and finally it will reach the Google server. Now, how do you get this next hop router information? The IP address of the next hop information is stored within your host. In fact, you configure it. This happens automatically when you use DHCP to get your own IP address, or you can also manually configure it. So root is a command that gives you information about your routing. Basically within this, the gateway is nothing but your next hop router. And as I mentioned, its IP address the host already has, and its MAC address is also typically cached, as we saw as part of ARP. Even if it were not cached, you can get, since you know the IP address, you can get the MAC address through what? That's right, ARP. Here is route in action. So it is giving a bunch of information. So same thing I said -n, that means don't do name lookup. In other words, don't give me the names, give me the IP addresses itself. So as you can see here, it is saying that this is the gateway router for this particular interface. So what are these other entries? We will deal with it later. So you just did one click and you saw so much happening behind. So in other words, one click has generated so many messages. So TCP dump and Wireshark are two tools that help you analyze what is happening. Basically, they capture packets that are sent and received at a host. And one very good thing about these tools is that there are many filtering options available. In other words, you can filter packets based on IP addresses, port numbers, so on and so forth. The TCP dump provides a command line interface, whereas Wireshark provides a graphical user interface. Typically, I prefer to run TCP dump at command line to capture the trace, and whatever trace is captured, I view the trace in Wireshark. But Wireshark can also be used to capture, but I find the command line arguments of specifying on the filtering options to be very convenient. So here is a trace of what happens when I click on this particular URL. By the way, I didn't use Firefox for this. I used a command line command called wget to get this URL. This is a very simple tool. It gives a very clean trace. One thing to note here, unlike in the previous example where I contacted the Google server directly, here within IITB we go through a proxy. So this is our proxy. So what happens at IITB is whenever you click a URL and you want the content, the proxy is the one that is going to supply the content. The proxy in turn establishes some connection to the Google server to get it, but proxy is the one that is going to provide the content for us. So for all practical purposes, you can just replace the Google with Netmon, and whatever steps we have taken earlier will work. Let's just see. So a few things to note here. This is the host IP address, and this is the DNS server's IP address. So first it's trying to get the MAC address of the DNS server. So this happens through ARP. Once it obtained the MAC address, it sent a query asking for the IP address of Netmon. Now, there are a bunch of, unless we cover DNS protocol, you probably won't understand this, but just for now, assume that it asked it for it and it gave a response in this particular fashion. It said, this is the IP address of Netmon. Now that it got the IP address of Netmon, it is now going to open a TCP connection to Netmon. So this is the famous TCP handshake. It's a three-way handshake. Again, we will cover it later. So then it is going to send a HTTP packet to this Netmon saying, I want this particular URL. This packet goes to the router, which in turn is going to forward it to Netmon. If you clicked on one of these entries, you will see the MAC address. So if you click here on the Ethernet MAC address, this MAC address corresponds to the router. So once the packet reaches Netmon, the Netmon has sent this particular message, because when you type google.com, you basically want to redirect to the Indian website. It gave, this is again part of the web server. It said this object has moved, and it would also have given a redirected address. So after this, you basically close down the TCP connection. Fin means I have finished this connection. You close down and you open another TCP connection to this redirected address. This is .co.in, and from then on you start getting data from the Indian web server. After that, it's kind of rather straightforward. A few other things to note is whenever you click on one of these things, it gives you more information. So here I clicked on the HTTP protocol, it gave what's happening here, and this is the content of the packet, all of this. Similarly, here I clicked on the TCP protocol and it gave me information on the TCP protocol. And again, this is all the packet content expressed in hexadecimal. So I will leave it here and let you experiment with TCP dump as well as Wireshark.